So we're going to do another applied optimization problem. Suppose a farmer is building a pen with a circular top and a rectangular base, and he's using 600 meters of fencing to create this pen. So a pen is a container for animals, usually pigs. What dimensions are going to maximize the area of this pen? Now we're already given a picture of what's going on to understand what the rectangular base of the pen looks like and the semicircular top looks like. But our job now, in order to maximize this, we're going to have to assign some variables. And we have to think to ourselves, what are the things that can vary here? If I'm looking for the dimensions that maximize the area of this pen, right off the top of my head, I can see that there's the length, maybe I'll call this the height of this side, we'll call that H. And then we have the length here along the bottom, I'll call that L. And then we also have the radius of the semicircle, I'll call that R. And that's a lot of variables, right? Before I get going too far, before we use all of these variables, what's a way that we could simplify this? I see in this picture, R is the radius of the semicircle, but it's also the radius along this half of the circle and this half of the circle. Namely that this length along the bottom is going to be exactly two of the diameter of the circle. Those two things have to be equal. In other words, I'm going to call L equal to 2R. You could also just call it the diameter, but I think that I like using radius. It's an easier thing for all of the other formulas we're going to use. So I've labeled some of the variables. Let's get on to the equations. We have a couple of equations that we want to deal with. It's telling us that we want to maximize the area of the pen. So I need to come up with an equation that's an area equation for this pen. So recall that the area of the base of this pen is just going to be length times width, or in this case it's going to be my variable, I called it h for height, times 2r, which is the length. That's the area of this bottom part. But I also need to have the area of the top semicircle. Recall the area of a circle is pi r squared. But I only want half of the circle, so I'm going to have pi r squared divided by 2. So I've come up with an equation for the area of the pen. That's only half the battle. Notice I still have two variables. I have r and I have h, and I want to get all of them in one, and I haven't used this 600 meter information at all. What is that telling me? That I only have 600 meters of fencing to fence this in? It means that the perimeter of the figure has to be exactly equal to 600. So the perimeter of my figure is going to be equal to 600 meters of fencing. And what is the perimeter? The perimeter is h plus 2r plus h. That's the rectangular part. That's 2h plus 2r. That takes care of the rectangle. And then I also need to add on, what is the circumference of this half circle? Well, the circumference of a full circle is 2 pi r, but because it's only the half circle, it's going to be half of that, so it's just going to be pi r. This is the perimeter of this circle. This is really helpful. Why is this helpful? Notice the area function is the thing that we want to maximize, but the area function unfortunately has two variables in it. So we're going to use this information to be able to write the area function only using one variable. And I think that it's easier to solve for h, so I'm just going to solve for h. So when I take this function and I solve for h, I have 600 is equal to 2h plus all of this other stuff can be simplified. That's just the same thing as 2 plus pi times r. I need to get h by itself, so I'm going to move it to this side and move the 600 to that side. And so I have 2h is equal to 600 minus 2r minus pi r. Maybe that's lame. I distributed the negative sign. If this algebra doesn't make sense, don't factor this. Maybe that's an unnecessary step. I'm going to divide everything by 2, and I get h equals 300 minus r minus pi over 2r. This is great. I now have an equation for h, and I'm going to plug that into my area function so that I get my area function in one variable. Area is equal to h, and this is a long way of writing h. H is equal to 300 minus r minus pi over 2r times 2r plus pi r squared over 2. Great! Now we have our area function. I'm going to distribute this r just to make it a little cleaner. Our area function is 600r minus 2r squared minus the 2 times the pi over 2 cancels, and I get pi r plus pi over 2r squared. So we have drawn a diagram, we've labeled our variables, and now using our perimeter equation we were able to get our area equation. Next, let's go ahead and take the derivative. And set that equal to 0 to find our critical points. The derivative of 600r is just 600. The derivative of negative 2 becomes negative 4r. The derivative of pi times r, recall pi is just a constant here, so the derivative of a constant times our variable is just going to be negative that constant. And then finally, by power rule, the derivative of pi over 2 r squared becomes pi times r. We get our derivative, we set it equal to 0, and now I'm going to try to solve for r. Oh dear. I missed all of that work because I was lazy and sloppy. I took my h, I plugged it in to my area function. Now I took the derivative and I'm setting it equal to 0. I'm setting it equal to 0 to find my critical point. So let's solve for r that makes this equal to 0. I'm going to combine my r terms and I'm going to move my non-r terms to the other side of the function. So I'm going to add pi to this side and subtract 600. So I get pi minus 600. And I'm going to factor out a pi minus 4. Those are the coefficients on my r here. Pi minus 4 times r, right? Because I have a pi coefficient and a minus 4 coefficient times r is equal to this. Now I divide both sides by pi minus 4, and I get my r is equal to pi minus 600 divided by pi minus 4. Great! So we found what our radius is, and if I wanted to, I could plug that into a calculator, and it would give me some nice number. Now that we know what our r is, we can go back to our h equation, and we can solve for what h is. In this case, h is equal to 300 minus r, and I know what r is. It's pi minus 600 divided by pi minus 4. Minus pi over 2 times r, which is pi minus 600 divided by pi minus 4. And we're done. You say to me, you don't like this as a final answer, right? That you want to simplify that. And I allow you to simplify that by plugging it into your calculator if you choose. So maybe you feel like this is unsatisfying, that the dimensions that we find from this problem are so cumbersome. But I think that I would rather leave it as an exact value than estimate for this example.